What's up, Algebra 1? I've been talking about graphing inequalities, linear inequalities. So we're trying to find all of the points, the x and y ordered pairs that would plug in and make this true for the inequality given. So I'm going to start by looking at the y-intercept, and that is 4. Now the idea is that when you plug in 0, 0 plus 4 is 4, so the very first point is here at 4. So let me get the pen going. So then next, we're going to study the slope, which means how does it change? When you plug in a positive 1, you've got negative 1 plus 4, which is 3. So when you plug in 1, you get 3. And we see that it trended down 1 over 1, so it's going to continue that linear pattern. And you can even test it here. Plug in 4, negative 4 plus 4 makes 0. So that's exactly why the point 4, 0 is on this line. Now, one thing I noticed in tutoring with students that were working on this today, this right here needs to be a solid line because of the or equal. Here in a moment when we do this one, this right here is a dashed line. So when we start at 3 and think about going up 4 and right 3, which we can't, we'll go down 4 and left 3, and this is what we're looking for. So when we go to think about the next part, there's a shading element to this. You've got to figure out where all the points are because it's not an equation anymore, it's an inequality. So you're trying to say, okay, this symbol is less than, so here's my starting value at 4, and I'm going to go less on the y-axis, and that would kind of force you to think about these values in here. Okay, so any point in this region will solve that inequality correctly, meaning you plug it in, you will get exactly something true. 0 is less than 0 plus 4. That's why 0, 0 is an ordered pair that would work when you plug it in to this inequality. So same thing here. This is a less than. So I started at 3. If I moved less on the y-axis, you would have all of the values that are below this line. Now, it does not include the points on this line because it's only things that are less than. I use this dashed line on number 4 because I don't want to suggest, like number 3, that points on the line work. These are all good solutions. They're all good to go. I'm going to mark them as green. But this isn't really red, but purple. It's kind of weird, but none of these points work on the line. That's what the dashed represents, is when you plug in those values that are on the line, it will fail. It'll say something like 6 is less than 6, or 2 is less than 2, which is not true unless you have that or equal, and that's why we do a solid line here. Okay, so number 6, really want to see what you guys come up with this tomorrow. So make sure that when you're solving for y, you remember a very special rule that we used on number 5. So let's talk about the system I gave you guys. This is where we're doing going next week. I want you to know this won't be on the quiz. It could be a bonus or something, but it's not counted against you since this is the first time we've seen it today. The idea is that you have 2. Here's where y is less than 1. Anything down here. Anything down here has a point, an xy point, that if you plug it in would be true. 0, 0. Well, 0 is less than 1, so 0, 0 is in there. Or any of these negative values. All of these values for the y is definitely going to be less than 1. Now you go up here, 2, 3, 4, and those fail that particular inequality. So I'm going to take this 3x minus y, put a pen on my hand here. I'm going to start solving for y here. So I'm going to take that 3x and move it to the opposite side. So that's negative y less than or equal to negative 3x plus 2. Now what I'm hoping you do when you do number 6 is that you take this negative value that's in front of y and you divide it into everything over here. So that turns into 3x, and that turns into negative 2. 2 negatives made positive 3. 1 of each sign made minus 2. So when we divide it by a negative, this sign has to change directions. It's now going to be a greater than or equal. So that's kind of the difficulty with this problem, is that you have to really understand how to solve for y, but specifically if you divide that negative, it's got a whole another rule that you have to keep up with, with that's less than turning into greater than. Okay, and I promise if I ever give you a question like this is actually what I'm trying to see if you can do. So whenever I do the line, I want to graph it using this -2. Okay, that point right here, which is going to be hard to show up in this purple here, but I got this line. It doesn't need to be dashed though, it needs to be solid, and it's going up 3 and over 1, up 3 and over 1, just like that in both directions. But it's got its own shading element. This right here says I need to go greater, y greater, it's all based on this inequality symbol at the end here, y greater than, so I need to go up, so basically anything, that looks cool, any of these are okay. Now, hopefully you noticed that there was an overlapping region, so I took a moment to pause the video. Maybe you didn't notice, maybe you did. I am erasing the overlap that doesn't work for both of them. So over here it was just yellow, over here it was just purple. Really the main answer is anything in this little wedge over here. Now points on the dashed line don't actually work. Points on this solid line, more in the bottom part, they do work. And that is really key in understanding this. Okay. So the next thing I want to talk about is substitution versus elimination, and this is really, if you understand how to solve equations, then you can really do this, but if it's something that you struggle with, then this can be kind of challenging. So let's practice together for a moment. I'm trying to substitute what I know y to equal, or x to equal, doesn't really matter, but this right here is the same as y. Like anywhere I see y in the other equation, I can replace it with -2x minus 20 because those are synonymous. Those are the same. So I'm going to go in here and I'm going to plug in that other y, exactly what I got. But I don't want to lose what I had. So I'm going to take a moment just to type that, just to see it. -x plus 5y, but not y. I'm going to plug in -2x minus 20. Sorry, it's kind of sloppy. So now I want to distribute and basically solve for x. So this right here is 5 times -2, which is -10x. And 5 times -20 is -100. And it's supposed to equal this -23. A lot of students miss that. They put +23 because they missed the fact that it was negative. Now there's another -x here. These are like terms, -11. We just want to put those straight together. And then I think you got it from here. See if you can solve for x. Try to see what x would equal. And then plug that in for the top one because it says what y would equal, -2x minus 20. If you know x's value, you can plug it into the other one. Okay, so for time's sake, because these videos are under 15 minutes, I'm going to start by doing something we probably haven't done too many times. I'm going to subtract 4y and put it on the other side. So now, basically, x equals -8 minus 4y. Those are the same thing. So it doesn't matter if you have y equals or x equals. You can really do this either way. So if x equals this -8 minus 4y, I can plug it in where there's an x. So -3 parenthesis plus 4y equals -8. One of the reasons why I always do this is because I want to make sure that mainly I get everything accurately from the last line to this line, and then I can stop and go back and fill in what I need. Well, that's not what I need. So once I have that substituted, you can solve for y this time. So start with distribution, and then try to get y by itself, and tomorrow we'll see how well you get that. Alright, elimination is a different method. It's when they're both in standard form and you can kind of combine the two inequalities if you add them together. Now, some are ready to go. This one's ready to go. This one kind of needs some work. And I put that multiplication symbol there so that we can kind of remember that you have to kind of use multiplication sometimes to beef one up so that it would cancel. Okay, so this one's ready to go. If you add these together, you get -4y equals -40. Okay, these add together to be 0, these add to be -4, these add to be -40. Okay, so now I want to divide both sides by that -4. And once I divide both sides by -4, I'm going to end up getting +10. So once you get y equals 10, you can use that to plug it in and get the other value. So I want you to try to plug it in because that's something we've been doing. But here's the next question. I'm trying to get these to cancel. Now this one was a little easier because I had -2 and +2. These are ready to go. Over here, not so much. You're going to have to multiply one of the equations to get something that would cancel. So you have to know your multiples. You have to know, like, can 6 become 12, or can this 1 become -10, and think about what would multiply. And you have to do the whole equation by that number to make them the same. So, for example, I could make this number be -12 if I wanted it to. Now I'd have to multiply it by -2 to make that happen. -2 times 6 is -12. That would allow these two to cancel. But I can't just do that. I have to multiply all of them. You have to multiply every single value times -2. So let's just try it down here. -2 times 6 we just tried was -12x. That works well. -2 times -10 is +20. Y. Now those don't necessarily match. -2 times -2 is +4. So when you get these to match and these are different, that means you're in like a normal problem. You're adding these together. 1 plus 20 is 21y. And you add these two together. -25 plus 4 is -21. I'm going to divide the 21 over and I get -1. So once you figure out that that's -1, you can plug it back in up here and see what you get. So this is multiplication times -10. Basically that gives you 6x plus 10 equals -2. And so I'm plugging it in up here. I'm now just got x. I subtract 10 to get -12, and then divide 6 and get -2. And now you have both numbers. Alright, so we're going to take a quiz over this tomorrow, see how well we're doing with it. And if you have any questions, please bring them to me tomorrow in class. Have a good day.